Good morning. Now we are passing to the next module, that is benzene and its aromaticity or aromaticity of benzene. Aromaticity. We know that benzene is an aromatic compound. When we say a compound is an aromatic compound, or what are the conditions for a compound is said to be aromatic. So conditions for aromaticity. Okay. Conditions for aromaticity. A compound is said to be, a molecule is said to be aromatic. It must obey certain rules. That rules are known as Hückel's rules of aromaticity. Hückel's rules of aromaticity. A compound is said to be aromatic. It must obey the Hückel's rule of aromaticity, and the first one is the molecule must be cyclic. The molecule must be cyclic. Second rule, the molecule must have a planarity. That means the molecule must be planar. So planarity of the molecule, or the molecule must be planar. Third one, the molecule must contain 4n plus 2 pi electron system. So 4n plus 2 pi electron system, pi electrons. And the last one is the pi electron system must be completely delocalized. That means delocalization of pi electrons for the stability of the molecule. So if a molecule can obey all these four, or the molecule is having all these four conditions, that means if the molecule must be cyclic, the second one is it must be planar, the geometry of the molecule must be planar. Third one is it must contain 4n plus 2 number of pi electrons, and the fourth one is complete delocalization of pi electrons for the stability of the molecule. So if a molecule can satisfy all these conditions, we can say that the molecule is aromatic. We can say that the molecule is aromatic. So let us discuss some examples for aromatic compounds. Okay. So keep it in mind, what are the conditions for aromaticity? The molecule must be cyclic. Second one is the geometry of the molecule must be planar. It must contain 4n plus 2 pi electrons, and the complete delocalization of these pi electrons. That means the pi electrons must be conjugated. There must be a conjugation in the pi electrons. Then only the complete delocalization is possible. So first we discuss monocyclic aromatic compound. Aromatic compound. Okay, example is as you know, benzene. Okay, as you know, it is benzene. Look at it here. This is benzene. So the first condition, it is cyclic. Okay, so the first condition is satisfied. Then second condition, the molecule is planar. Of course, because you can see that all the carbon atoms are in the same hybridized state. That means sp2, and you can see that all the carbon atoms and the hydrogen atoms are in the same plane, and hence the second condition, what is that? Planar. The molecule is planar. The planarity of the molecule is maintained. And the third condition, 4n plus 2 pi electron, 4n plus 2 pi electrons. Okay, pi electron. Look at it here. You have to count the number of pi electrons. This is a pi bond. A pi bond is formed by 2 pi electrons. So 2 plus 2, 4 plus 2, 6. So what is the number of pi electrons? 6 pi electrons. 6 pi electrons are present in benzene. 2 plus 2 plus 2, 6 pi electrons are present, and we can see that when you give value of n, you can give the value of n can be 0, 1, 2, etc. Now when n is equal to 0, we can see that first you put give different values of n. First we are giving n is equal to 0. So in this equation, 4 into 0 plus 2, that means it is only 2. Now you can give n equal to 1. When n equal to 1, what do you get? 4 into 1 plus 2, that means how much you will get? 6. That means this equation can satisfy the 6 pi electrons. When you put n equal to 1, you are getting 6, and that is the number of pi electrons in this system. Okay. So that is matching. That is matching. When you give n equal to 1, what you are getting here? 4 into 1 plus 2. How many pi electrons? 6 pi electrons. Of course, this compound is having, this molecule is having how many pi electrons? 6 pi electrons are present. That means it is matching with the formula when n equal to 1. So when n equal to 1, what you will get? You are getting 6 pi electrons. So that's condition also satisfied. Then the last condition, complete delocalization of pi electron. What do you mean by complete delocalization? You can see that here is conjugation, double bond, single bond, double bond, single bond, double bond, single bond. That means there is a conjugation. If there is a conjugation, you can see that this double bond can be shifted to here. So what will happen? When this double bond is shifting between these two carbon, this will come here between these two carbon. That time this bond will be shifted to here. This is what is called delocalization of pi electron due to the conjugation of double bond. Complete delocalization is possible. So delocalization of a pi electron. So this molecule benzene is satisfying all the conditions of Hückel's rule. So we can say that benzene is aromatic in nature. Clear? Another example for cyclic aromatic compound, that means here it is monocyclic. Now let us take some polycyclic compounds. Polycyclic aromatic compounds. Polycyclic. Look at it here. Okay. Here is double bond, double bond, double bond. Then this is single. Again, this is double, single, double, single, double. Okay. This compound is known as naphthalene. Again, look at it here. Naphthalene. You can see that this is a cyclic compound. What type of polycyclic? There are two fused ring system, fused benzene ring system. Okay, this is fused benzene ring system. There are two benzene rings. Okay, and first condition, what is cyclic, of course. And the second condition, the planarity of the molecule. You can see that the molecule is planar. And the third condition, you look at it here, 4n plus 2 pi electron, 4n plus 2 pi electrons. Look at it here, how it is satisfying this condition, 4n plus 2 pi electrons. First you count the number of pi electrons in this system, 2 plus 2, 4, 6, 8, 10. What is the number of pi electron in the system? 10. When you get, if you are getting the same answer, same number 10, when you give a number for n in the equation, when you can see that when n equal to 2, in this equation, what do we get? 4 into 2 plus 2, what is that? You are getting 10. That means the number of pi electrons is equal to 4n plus 2 pi electron system. What is that? Both are 10. When you give n equal to 2, you are getting 10, and that is equal to the number of pi electrons in the system. Here also 2, 4, 6, 8, 10. That is equal to when n equal to 2. Okay, so it is satisfying the 4n plus 2 pi electron system. Another example for polycyclic aromatic compound, that is anthracene. Look at it here, anthracene. So here you can see that 3 benzene rings are fused together. How many benzene rings? 3 benzene rings. Okay, so here is double bond, double bond, double bond, single bond, double bond, double bond, double bond, double bond. Okay, so look at it here. In this compound, you can see that how many benzene rings are fused together? 3 benzene rings. First condition, this is cyclic. What type? This is polycyclic. Okay, fused ring system. And the second condition, there is a planarity in the molecule. Third condition, 4n plus 2 pi electron. Look at it here, 4n plus 2 pi system. 4n plus 2 pi system. Okay, look at it here. What is the number of pi electrons? 2 plus 2, 4, 6, 8, 10, 12, 14. What is the number of pi electrons? 14. and whether it is matching with our formula. Okay, we can see that when n equal to 3, when n equal to 3, what we get? 4 into 3 plus 2. What do we get? We get 14. That means it is matching with 4n plus 2, 5 electrons. And the last condition, complete delocalization. What do you mean by complete delocalization? Look at here. This bond comes here. Okay, then this can come here, or this bond is going here. Clear? Then what will happen? This can come here. Then what will happen? This will go here. Okay, or what will happen when it come here, this can go here, then this will go, this will go. So you can see that when you draw this resonance structure, when you draw the delocalization of 5 electrons, you can see that a complete delocalization is possible in benzene, naphthalene and anthracene. And in all these three compounds, benzene, naphthalene and anthracene, you can see that benzene system is present. Benzene system is present. In benzene only monocyclic benzene system, and in naphthalene there are 2 benzene rings fused together, and in anthracene how many benzene rings fused together? 3 benzene rings fused together. That means in all these aromatic compounds you can see that benzene rings are present, and such type of aromatic compounds are known as benzenoid aromatic compounds. Benzenoid aromatic compound. What do you mean by benzenoid aromatic compounds? Aromatic compounds which contain benzene system. Aromatic compounds which contain benzene system are known as benzenoid aromatic compounds. Example, benzene, naphthalene, anthracene, etc. Clear? So this is benzenoid aromatic compounds. Okay. Now we have non-benzenoid aromatic compound. Look at here. Next topic is non-benzenoid aromatic compounds. There are many compounds which do not contain benzene ring, but they are aromatic in nature. Now we discussed benzene, naphthalene and anthracene. All these compounds is containing benzene ring. But there are many compounds which do not contain benzene ring, still they are aromatic in nature. These compounds can be stabilized by delocalization of pi electrons, and such compounds are known as non-benzenoid aromatic compound. Example, look at here. I take an example for this is NH, and here it is a double bond, and it is a unshaded pair of electrons. This compound is known as pyrrole. What is this one? Pyrrole. So this pyrrole does not contain benzene ring system, and still it is what is that aromatic compound. This showing aromaticity. Okay. So pyrrole is an example for a non-benzenoid. This do not contain a benzene ring. Another example is look at here. Here it is double bond, and here it is oxygen. Here it is oxygen, and this compound is known as furan. What is this one? Furan. Okay, another example is again this is 5-membered. Here it is sulfur, and here is double bond. Here is a pair of electrons. Here also. This is known as thiophene. And the last compound, here it is, this is not benzene ring because here it is a nitrogen. Here it is nitrogen, and here it is alternate double and single bond. This is known as pyridine. All these compounds, even though they do not contain a benzene ring system, they are aromatic in nature, and they are known as a non-benzenoid aromatic compound. Now let us discuss how they are showing aromaticity. Okay, how they exhibit aromaticity. First you take pyrrole. Okay, pyrrole, you can see that nitrogen. Here you can see the nitrogen. Nitrogen is having, say, 1, 2, 3 bonds are making, and what is remaining? a pair of lone pair electron is present. Lone pair electron. Okay, there is a lone pair electron. Now, lone pair electron or unshared pair of electrons. Now you can see that when you look at pyrrole, so this is double bond, single bond, double bond. So this is not the pi bonds or pi bond is not in conjugation. This is not in conjugation because see, if it is shifting to here, this will come here. So here is there is a not double bond. So this is not in conjugation. Pi bonds are not in conjugation. But we can see that this unshared pair of electron, this pair of electron present in nitrogen will undergo delocalization. That means if you take pyrrole, look at here how the conjugation or how the delocalization is possible. Here it is nitrogen. Nitrogen is having an unshared pair of electron. Here is double bond. Here is double bond. And look at here. This double bond is shifting to here. Correct? Then this will come here. Okay. Then what will happen? This pair of electron, this is pi electron, this pair of electron will be shifted to here. Understood? So there is a complete delocalization of pi electrons. That means this unshared pair of electron that will also take part in the delocalization of pi electrons. Keep it in mind, these are pi electrons because this nitrogen is sp2 hybridized. All these heteroatoms, these are called heteroatoms. These atoms are a sp2 hybridized state, and the electrons present, unshared pair of electrons that are pi electrons, that pi electrons will also involve in the delocalization of pi system or pi electron cloud and will thereby stabilize the molecule. And look at it here. Now we are looking at other conditions. First one is planarity of the molecule. Of the molecule is planar, and the second condition is first condition cyclic, of course. Second condition, the molecule is planar, and the third condition 4n plus 2 pi electron system. 4n plus 2 pi system. Look at it here, 4n plus 2 pi, whether it is satisfying this 4n plus 2. Look at it here, when n equal to 1, what we get? 4 into 1, that means 6. Now you count the number of pi electron in the system. This is 2 plus 2, 4, and of course you have to count this unshared pair of electron. This is also you have to include. So what is that? Total is 6. How many pi electrons are present in the system? 6. Correct? So here is 2 that is present in the pi bond. This is also 2 present in the pi bond, and these 2 electrons, that means unshared pair of electrons present on the nitrogen, that is also pi electrons. So what is the total number of pi electrons in pyrrole? The total number of pi electrons is 6. So when you put n equal to 1, you are getting how many? You are getting 6. That means it is satisfying 4n plus 2 pi electron rule. Okay, and the last condition is complete delocalization. See, a complete delocalization of pi electrons is possible. This pi electron is shifting to here, this will come here, then this unshared pair of this pi electron will be moved to here. Okay, so complete delocalization of pi electrons is possible in pyrrole. Next you look at furan. Okay, next look at furan. Furan, okay, again the furan, the first condition cyclic compound. Of course the molecule is planar in nature, and the third condition, look at here, what is the number of pi electrons, or before that how this complete delocalization is possible. Look at here, oxygen is having here it has 2 unshared pair of electrons. This is one pair and this is another pair. Okay, but we can see that only one pair of unshared pair of electron will take part in the delocalization. That means complete delocalization, this will be shifted to here, correct? And this pi bond will be shifted to here. Only this pair of electron, this unshared pair of electron will take part in the delocalization. So we have to consider the electron pair which is taking part in the delocalization. That only we have to count for the number of pi electrons. So here the number of pi electrons involving in delocalization is 2 plus 2, 4, and only these two, this pair of electron is not taking part in the delocalization, so no need to count. Therefore, number of pi electrons in furan is 6. Actually, what is the total number of pi electrons in furan? It is 8. But you can see that only these two is taking part in the delocalization. So you have to count only 2, 4, 6. This you no need to count in the because that pair is not taking part in the delocalization. So pi electrons in furan taking part for delocalization is 6, and we can see that in 4n plus 2, what is that, when n equal to 1, what we get 6. So it is satisfying 4n plus 2 pi electron rule. Okay, and keep an important point, when you count you can see that the total number of unpaired pi electron is 8. But since only one pair is taking part in the delocalization, you make it 6. It is in agreement with the 4n plus 2 pi system. Okay. And when you come to thiophene, the same case also in thiophene also, sulfur, oxygen and sulfur, they are coming in the sixth group. Therefore, their outer electron is 6. 2 electrons are used for making 2 bonds, and remaining 4 unpaired electron, that means 4 electrons are there, that means unpaired electron. This is one pair and another pair. Same, sulfur is also belonging to the same group 6. Outer electron is 6, and 2 electrons are used for making these 2 bonds, and the remaining 2 pairs of unshaded pair of, this is one pair and this is another pair. Look at it here also, what is happening. This bond will be shifted to here, this will come here. Only one pair, this pair will take part in the delocalization. So here also you have to take what is the number of pi electron taking part in the delocalization is 6. Therefore, when n equal to 1, you get 4 into 1 plus 2 is equal to 6. It is satisfying 4n plus 2. Clear? And even though there are 8 pi electrons, total altogether there are 8. But if you look at it here, in the unshaded pair of electron, only one pair of electron is taking part in the delocalization. You have to take that pair of electrons, so it will become 6. And the last one is pyridine. Pyridine, of course, 2 plus 2 plus 2. What is the total number of pi electrons taking part? So it is here, it will come here, and it is coming. Of course, in nitrogen there is a pair of electron. This unshaded pair of electron will not take part in the delocalization. Only these bonds are taking part in the delocalization. Here pi electron is 6. When n equal to 1, you are getting 4n plus 2 equal to 6. Okay, clear. So these compounds or these molecules which do not contain benzene ring system, still they are aromatic in nature. Why they are aromatic in nature? Due to the involvement of the unshaded pair of electrons present on these heteroatoms. So this is heterocyclic aromatic compounds. Heterocyclic aromatic compound, which one? Pyrrole, furan, thiophene and pyridine. They are stabilized by a delocalization of pi electrons present on the heteroatom, present on the lone pair electron or unshaded pair of electrons present on the heteroatoms will take part in the delocalization and will stabilize the molecule and will show aromaticity. Such compounds are known as non-benzenoid aromatic compound. Non-benzenoid aromatic compounds. Okay, so thank you. We continue in the next class.